Hello. I even looked at my list and didn't. Let's go back here. Oh, the cat cam is blown out. If you're just watching this, take a look in the notes or in the description below. There will be time codes to get you shifted in. I'm a little behind, so it'll be a little bit. Let's see if we can't poke. If I can't poke the cat cam here. Here we go. No cats in the window. It's quite bright. But Finn is actually very cutely. I need something to put under it. Make it a little taller. No? Oh, come on. Whoa. Yeah, sorry. I'll put a time code in just a second here. Oh. Then what I won't do for you. Oh, come on. I have a clip that's holding the cat cam to the desk. That'll do. Sorry, folks. Moto Timo is asking, what kind of cameras do you use, Tan Newt? This one of the cat licking her butt is just a C920. I think it's a 920, just a Logitech webcam. And then this one is a Sony, I can't remember it now, ZV-1? Is that what it is? So here's the cat cam. So cat cam's not that great a quality. It's just a webcam. Yep, ZV-1. Thank you, Mr. Certainly. Audio is good. It's a little weird in my headphones, actually, but I won't mess with it since it sounds good to you all. Yeah, I was running a little late. I've been debugging stuff. So let me dump a time code in for David. So timestamp is here. Yeah, it's just a couple seconds off. Okay. Before we get started, I'll just take a say hi to everybody. So hello Braden, hello Mark, hello Hugo, hi Unexpected Maker, hi Jim, hi Johnny, hi Hugo. Johnny asks, so when are we moving away from this totally uninteresting 2040 chip? It doesn't even have Wi-Fi. True. Hi Truan, hi Bruce, hi Johnny again, and Gareth. Soon, hopefully. Like once we can get everything settled out. The overhead is a Hovercam Ultra 8, and I do have it set up today because I have some stuff to show. My desk is really dirty, so hopefully that's okay. Hi Herbert, hi David Buchanan, in case I had another David. Bruce says, yeah, I don't really plan on getting back to the S2 myself anytime super soon. I really want to do the BLE workflow stuff, which will benefit the longer term ESP work. But for now, that's not my plan. Oh, you know, let me make sure that... Whew! I was like really trying to get things sorted out earlier. So I'm like, haven't gone through my email. I was just like heads down on stuff. So let me pause these playbacks that are going. Okay. And yeah, like I have both Restream and YouTube open, and it's just like, I don't need to watch myself. Hi Dave. Bruce says, I send super thanks to Dan and whoever else seemed to fix the Wi-Fi I2C issue. Yeah, I think that's Dan. I know a couple other folks looked at it. Lucian and Jeff also looked at it. Probably more people that I forget. Gareth says, I've been thinking about the BLE workflow feature. I'm convinced it's really important. Yeah. Daniel says, UPS just delivered a black box with a flower on the outside. Excited to pull out the Feather RP2040. Great. You can help me test the stuff that I've been fixing today. Hello, Muhammad. Okay, I didn't say hi to the folks in the Discord chat either, so let me just do that. If you want to join the Discord and you haven't yet, you can go to the URL adafru.it/discord. So here we've got... Gary Z, Mr. Certainly, Papa Romeo Mike, Hugo, Jim, Gary Z, Bruce S, Mototimo, David G, Paul SK, Hugo, Mr. Certainly, Jose David, Luz there and Telemon, Hams Labs, Big Bob, DCD, thank you again, as always. Hamslab just got a new office chair delivered, but I need to wait to put it together until the end of this. Oh. The Tinkerer says, there's a cat. I approve of the cat. She heard you. She decided to jump down as a result. But today's cleaner day, so I doubt she wants to get out of here. Okay, let's do housekeeping. I've procrastinated long enough. Keba Kanye says, almost never made it to this. Sun is out in Seattle. I'm in Seattle too. And the sun is out. It's nice and bright here. Slinky Tangle says, my cats are watching today. That's awesome. All the more cats watching, the better. Okay, so let's do housekeeping. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. I forgot how to remember. CircuitPython is a beginner-friendly version of Python designed for microcontrollers, which are these little tiny computers, and they're really inexpensive as well. Let me just product showcase mode. And this is a Cutie Pie. This is just a SAMD21 Cutie Pie, but the relatively large black chip there is a computer all of itself. So that's what a microcontroller is. Adafruit is an open source hardware and software company based out of New York City. I work remotely for them, though, so I'm based in Seattle, and that's why I announce things in Pacific time, because that's my time zone. Speaking of which, and I forgot to put this in the notes, although David already beat me to it, is the U.S. is changing daylight savings this weekend. So next week, if you're outside the U.S., next week will be at a different time for you. So just be aware of that. And I think next week's Friday. I think next week's Friday. Let me just double check on my calendar here. Yes, it's gonna. I might have to like get out of here a little early because Spook has a vet appointment afterwards. But yeah, next week will be on Friday. I talked about Adafruit. If you want to support me and support Adafruit, you can go to adafruit.com and purchase hardware from them. There's lots of interesting stuff. You want to come up? Vin decided to get some lap time. Deep dives happen every week, normally Fridays at 2 p.m. Pacific, but occasionally shifted to Thursday at 2 p.m. A couple weeks from now, it will be going to go skiing on a Friday again, so I will let you know. But next week is on Friday. Typically go for 2 hours or more, and questions are welcome. So if folks have questions now doing that, let me know. Heads up that Spook, the other cat, there's two cats in here. One is on my lap. That's Vin, and the other one is Spook. He is epileptic, so occasionally he has seizures. So if I'm like on the stream but not talking and like not paying attention, that's why I'm just making sure he's okay. He's been doing really well, though, so I don't expect it to happen. Okay, let's do some more hellos. Yeah, it's nice. Maybe you should change the cleaner day for the cats. I don't think so. I mean, like, this is a day that Vin is on the stream because I usually kick her out. Exactly. That's what Hugo's getting at too. Um, yeah, next week we'll end a little early, probably go a little bit later today. Yeah, it's just nice. It's super nice out. Um, yeah, the cleaners do everything but this room. This room is, I gotta clean it myself. Okay, more hellos from YouTube. Um, is sun in Seattle even possible? Yes, the Tinkerer it is, but we just don't tell people so they don't move here. It does rain often, but we do have really nice stretches of weather like we're in the middle of right now. Hi, Hybotics. Hello, Charles. Hi, Jim. Andrew Reed from Cornwall. Thanks for staying up and watching. And hello, Dave. Odessa. The clocks go forward there on the March of 28th. So there will be a 2-week. I think we're the 14th. So I think it'll be a 2-week gap. Okay. So what do we want to talk about? I hadn't even. Ooh, here's a question. So if you have questions, put them in the chats. I'm trying to watch them all. Saraceum on Twitch asks, how do you keep the cats away from the workstation and hot irons? So the soldering station I have is set up in the laundry room, which is like a room next to me. And they don't just, I do have stuff out, and they do get up there occasionally, but generally they don't. Generally they follow people around. I was doing some soldering earlier this week, and it reminds me that's what I should start with. And I'll show that. I was like, where'd it go? So I do have to kind of keep them away from that, but the soldering iron's not hot all that often, because I don't do a whole lot of soldering. I mostly do software. Luz there in Telemon says, that's exactly right. It's a secret that Seattle has with good weather is gorgeous. Don't tell anyone. Hamslab says, we got a new tagline here, Buffalo, that says, keep Buffalo secret. Oh, okay. We have a couple questions, which is great. Hi, Tinkerer from Georgia. Your dad's watching too. That's awesome. Saracine says, it's an honest problem over here. Our cat Frito gets over everything. Yes, they do. They do get over everything. That's why I always have, whenever I show PCBs and stuff, I have to apologize for the cat hair. Okay, more questions. So from Muhammad Hussein says, I have a question. How far is CircuitPython's implementation of asynchronous I/O scheduler? Micro async I/O. So we do have async and await keywords enabled in CircuitPython. That's thank you to Warrior Wire within the community. And they created a scheduler called Tasco, which is what I would recommend looking at. I've not actually used it, so I can't tell you like exactly where it is with everything. But it is enabled. So, this is something we talked about before where, Adafruit folks may not work on something, but like we're happy to incorporate contributions from the community as well, right? The goal of the project is to be larger than Adafruit and have a lot of folks all working on it, like doing the things that they're interested in, like most open source projects. So yeah, how far is it? It works, and the one of the things we did do as we did the PR for async and await was just to make sure that like all the objects it used from the Python side looked like they were normal CPython objects. So it's very bare bones, but yeah, it's a start. It's just not something that we've like poured a lot of hours into. Kieran Clark says, we don't do daylight savings as the extra hour of sun fades the curtains. Yeah, there's a lot of discussion here in the US not doing that. Lantertronic says, is there a time you'd pick the STM32F405 Feather over the SAMD51 Feather? They seem similarly capable, but Adafruit seems all in on the SAMD51. I've done a ton of work with the SAMD51, so I wouldn't I probably wouldn't do that either. And I haven't looked at the STM32F405 to know a whole lot about it. I think one thing that's kind of interesting is that the F405 has core coupled memory, which could make it a bit speedier. But generally, I did a lot of the implementation on the CMD51, so that's just what I'm more comfortable with. Yeah, I think, like Mark says, STM32 is amazing. Like, that's kind of why we did it. The Feather, I think, was to like dip our toes into the STM waters. Okay, Big Bob has a question. It says, my Feather RP2040 are to be delivered today, ordered on Monday. There was no Feather airlift, so I ordered one on digikey, which is not yet even shipped. I'm surprised by that. Digikey usually ships basically same day for me. Ordered another airlift yesterday from Adafruit when it came back in stock, so which one will show up first? I think that depends a bit on where you are in the world as well. But I generally have really good luck with digikey from Minnesota to here in Seattle. It's usually pretty good. USPS though, let me tell you, I had a lot of trouble with USPS from OSH Park in particular, and from digikey as well. Big Bob says, will either of the two Feather matrix wings work on the RP2040? I think so, but I can't remember which one. I know the person to ask would be Jeff Epler, who's tested it. So just you're on Discord, just ping at Jeff Epler and ask which of the two it is. It might be a third one too. There's some weird pinout constraints with the matrix stuff. Lodatima says, in the US, we need federal change to allow us to ditch daylight savings time, even though the entire West Coast is colluding to drop it. Yep. Yeah, USPS. Yeah, I've started doing FedEx. OSH Park has really pretty cheap FedEx stuff right now. FedEx shipping. Hi, MD Roberts. Yeah, I live in Seattle and OSH Park's in Oregon, and I had an order from OSH Park like get lost, and it like was gone for like 2 weeks, and then it showed up in Tennessee and then made it pretty quickly back as well. Mike Mokum says, surprisingly few felines in this cat video. Sorry about that. There's one over there and there's one here. They're just not. She moved. She doesn't like when I talk, so she gets all upset. Interesting that the shipping has been slow from digikey. Maybe they're switching warehouse to the new warehouse. Todd Butt says, hey Tanu, thanks for the Feather RP2040 flash speed fix. I think I might have made it too slow, and we'll get into that in a bit. Okay, so let's show some stuff off. MD Roberts says, got my RP2040s today by USPS, only 3 days to Canada. Good. Okay, let's go to the overhead. So the thing that I was waiting for from OSH Park is, you can see my OSH Park mask thing. I think I showed this off last week, but this is my USB micromod design that I did. And I'll set it down and I'll zoom the camera in. So what this design is going for is that I found these USB cases on digikey from Hammond, and you can see that they have like this notch. They have a notch here where the USB-A connector is supposed to come out. Now, unfortunately, I put the USB connector on the wrong side. So it doesn't actually, like I fit checked everything before I soldered the USB down. So I know that like my V2 will fit correctly. But I can't actually fit this fully populated version in the same thing. Oh, and Mark asked, are you using debug-edge in anything? Know anyone else who is using it? Yeah, look. So debug-edge is an open standard that a few of us created for access to SWD connections, and Mark did some of the design on it, which is awesome. So I actually just used it on this board so that I can get access to the SWD lines of of the micromod. So what this is it's a micromod on one side, which allows you to change kind of the brains of it. It's from SparkFun, so it's kind of a standard pinout. Now this one is the not the RP2040, the NRF52840, which my goal is to. The reason I picked this is because I want to use the broadcast net stuff I did, so BLE advertisements to transmit sensor data back. So I got that. The Tinkerer says, my dad says that when our RP2040 feathers come in, I can try CircuitPython. Perfect. It's a really good board to try with CircuitPython. And then what I have here is I actually am using these 10-pin flat flex connectors. And I showed this a few weeks ago, but I got some different versions of it. So what you can do is they're quite tiny, but there's a little flap on most of these. So this is a flap, this one under here is a flap, and this is a flap. And I can open it. So the idea is to make sensor boards that are very low profile, but are still solder free and easy to put on. So here you can see that I have like a 5 neopixel board. This is done on OSH Park's Flex PCB stuff. So I have that one. And then this one's an SHT C3, which is a temperature and humidity sensor, and they're really small. But you can see I actually use different versions of these things. I wanted to kind of like compare how well they worked and how easy they were to hand solder. So this is the Hiroshi one. This is the Molex one. This is a TE connectivity one. The Hiroshi is the cheapest. And then this one is an Amphimol, but it's a slider, and I hate these ones. I'm sure it's like much more like solid, a much better mechanical fit, but I can't stand working with them. So what this is this sensor is it's a ambient light sensor. It's the VEML 7700. And I put 2 footprints on it so that you can orient it different ways. And now that I think about it, yeah, you can orient it like right angle all in the same one because of the way it's done. So I'm gonna put these back before I forget where they were. I do have code on here, and it does work, which is great. So I ordered a V2 that this one that slides, it's just a huge pain. I don't like it because like it slides out unevenly really often, and I cut my nails recently, so that makes it harder too. Okay, so that one's on there, and this one was on the TE one. So you lift the little flap, and then you just kind of insert it and close the flap. That has a like nice locking thing, and then I'm gonna put it here in the Hiroshi neopixels here. So the pinout it's a 10-pin pinout. It only has ground and 3.3 volts, so I'm running the neopixels at 3.3. It has one analog pin that is unique to each section. It has one digital pin that's unique to each connector, and then it has shared I2C, shared SPI, all in 10 pins. So I think that's kind of the thing. Okay, nice. Mark got 250 PCBs today that have the debug-edge. Lancertronic says, what's the best way to get word to Lamore that Scott deserves a raise for being so awesome? I negotiate with them every year what my billing rate will be, because I'm a contractor. But they pay me really well. If you follow my Twitter, you probably saw what they pay me. It's good to be open about how much people get paid. Let's see. Does OSHPark do SMT assembly like JLC PCB does? No, they do not. But they do work with OSH Stencil to provide stencils. Let's see. Luz asks, how does OSH's Flex PCB compare to the Flex PCB on the neopixel dotstar strips? That's a good question. I thought about that. I didn't grab one. I don't think I have. I don't have one on me here. It feels kind of similar. The feel of it does vary a little bit with like how much copper you have and what orientation it is. But you can see it does flex a little bit out because I actually have a fourth connector here. And then this one here is, I put it too close to the hole. So I shifted this one in a bit as well. Johnny points out that you can support me on GitHub if you like to. I do have GitHub sponsors open, so if you want to do that. But really, like, Adafruit treats me really, really well. I'm very lucky, and my wife works at Google, so like, it's not a problem. Okay. Looks on Twitter. They pay you only in cat toys? Oh well. Yeah, so sorry, I don't know a ton about the difference in the Flex stuff. Okay, since we have the overhead open, let's show what I've been working on. So I got 2 feathers. I think I didn't see any other questions. Let's talk about what I've been doing. So here's one feather RP2040 that I got. And I did actually get these. I showed these last week. I got this goodie bag from Lamore that is a bunch of flash chips. There are only 2 different flash chips in here, but there's multiple. And I also got some RP2040 chips. So I need to respin my Game Boy cart. That's on my to-do list after I finish this drywall. I got to finish the drywall. I made a deal with my partner, Becca. It said, I really want a new soldering iron, but it's kind of expensive. So I've got my eye on like a JBC. And we've been meaning to finish this drywall in here. So the deal is that I can order the soldering iron after the drywall's done. So I've got motivation to do it this weekend. Okay, so yeah, Game Boy will be interesting too. But so the reason that she sent me all that stuff is she tried to put the 4 megabyte on the feather, and it didn't work. And so what I've been doing is around the same time that I started doing it, Jeff redid some of the flash stuff, and we started to get a lot of reports just in the last couple of days of people having like weird reliability issues with the Feather RP2040. So luckily, what I decided to do was I actually decided to put together, I'm just going to move the camera here, this feather. So I got 2 feathers, and I sacrificed one of them because LadyAda had pointed out to me that Adafruit stocks these sockets, which did I talk about these sockets last week? I'm not sure. So these sockets are pretty neat. What you can do is, let me unplug it. I'll show you. So since we're diving deep, so I'll unplug it. And what you can do, there's a little Captain Tape tab, and you can just pull it up and unhook it. And then the 2 wires go away, and you can pull the flash chip out. So what it does is it's allowing me to test the RP2040 with a variety of flash chips without having to solder different ones on and off the board. So this is a 4 and this is an 8. So I'll just pop this in. And I think the orientation is right. The pin 1 is up here. And what you do is you just take this thing to keep it down, and it snaps on, and now it's connected, which is super neat. So that's really neat. What I did, it took me a while. I'm getting better and better at soldering, and there's definitely a cat hair on here too. But not only did I put the socket down, that I got a cat hair stuck in the socket. Okay, got it. So what I also did is because I like to watch over the Salea all of the flash transactions. That's a really good way to debug it. And we talked about this last week. I think Alvaro was like, "Oh, you're debugging by observation." So I was doing that last week using. I think this is what I was doing last week. Is these clips are awesome. So if you ever do spy flash stuff, these clips are epic because you can just clip them down right onto the flash. Can't do that with this socket though because the flash is in the socket. So what I did when I was doing all the soldering is the socket goes on the footprint of the flash, and I had to cheat it a little bit because there's resistors right next to it. But then I use wire wrap wire that's like this 30 gauge, super tiny wire wrap wire to go from each pin, almost all the pins. I ignored the power pin. But I have these tiny little wires, and they run just out to these out to the regular holes, and I can't do anything else with this feather because at least these holes of the feather because they're connected to the flash. But that's a really good technique if you ever do want to break a signal out and you're using these tiny wires is like don't break from these tiny wires straight to the thing you're going to read the signal with. If you have an intermediary here, it makes it a lot more reliable. So the tiny wire goes from here, like the pin leg to the hole, and then the holes I put. We have these awesome. I talked about these on the deep dive before. These silicone wires, and they're pre-crimped. They have ends on them, but what I do is I love the silicone so much. The silicone wires that I just cut them in half and strip the end and then soldered them down. So they are going into the Salea, and I was trying to keep it short because the longer the wire is, the slower you have to clock the flash because you have like more wire to deal with. But yeah, so I got that set up and I was having some reliability issues, and there's a couple things I should follow up on. Last week we left off where I was like not seeing a clock signal and I was really confused. It turned out, this is so silly. On this harness, let me switch to not the desktop. On this harness here, there's two different ends, and I had swapped the two ends so that they were in the wrong spot. So I was like yellow to yellow and blah, 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 but it was plugged into the wrong thing that wasn't yellow. So that was one of the things I found. And then the other thing I found was we were working on converting from assembly to C. And the other thing I found is that I was doing one control 0 register, but there's actually two. So I got the basic version working with C. So that's exciting. What I was working on after doing all the soldering was trying to get the more advanced initialization working from C as well. And I also, I just chatted with Luke a bit as well and was like, I'm converting it to C because it doesn't make sense to me why you would do it in assembly. And he pointed out that like with the C SDK for the Pico, they want to support a lot more compilers, and compilers are going to vary on how they compile that C down. And when you're trying to do it in 252 bytes, you really have to look at it. And like we saw last week that like I was very much like, take my C, compile it, look at what the assembly is to make sure that it wasn't being very excessive about it. So we were having these reliability issues with the Feather, and the reason that Lamore had sent this stuff to me was that she had been unable to get the 4 megabyte version. Mohammed says, how big a flash chip can we use with the Metro Feather M4 Express? I tried mounting 64 megabit, but CircuitPython didn't support it. So for the M4s, for the SAMD51s, you'll have to look and make sure that you change the flash. If you're changing your flash, you have to rebuild CircuitPython. Because CircuitPython will CircuitPython does initialization, and that's something I want to do as I'm redoing this. Is I really would like to move to a model where we don't hard code the size. We read the size from the flash chip. That will give us a little more wiggle room to like have some interchangeability on flash chips. Now there's a lot of settings, and that reminds me, one thing I did do is I also did some improvements to Cascade TOML. So I have this like nvm.TOML. I need to push these. I haven't actually pushed these. So let's go to the desktop. So here I am in nvm.TOML, and I need to source my development version of Cascade TOML. But then what I did is I now have a tabulate command, which allows me to output all of the settings for all of the chips. So I loaded that into Google Docs, the CSV version. And now what I can do is I can look and see like, okay, for this is too tall. Like for all of the Giga device flash chips, here's the different sizes. Here's the capacity values as read out from the flash chip. And then, so this kind of shows the cascading. So like this row is all the settings that are the same amongst all the Giga devices. And then you can see that there's differences here based on like size. Like even though they're the same series, the different sizes generally are released at different times, which means they might actually have different functionality, which is kind of a pain. So I've been staring at this a lot and trying to figure out, like, as we look at, like, LadyAda is looking at, like, what chips to put on the QTPy and the ItsyBitsy, trying to figure out which ones work and, like, what the optimal size is as well. So I was using these to try to figure out, like, what our ideal targets are. So, like, these winbond chips are going to be pretty popular. That's what's on the Pico. That's what's on the Pomona stuff. So, like, those are probably going to be closer to what we want. Anyway, so I did that, and I need to push it. I haven't actually pushed the code. If you don't want CSV and you just omit it, it uses this library called tabulate, which it doesn't really show very well here because it's wrapping for how wide it is. But it actually does like a terminal sort of format for the tables as well. So that's, I wanted to do that just to get like be able to like zoom out and see the whole picture of how all the settings relate to another. So I did that. And then I've been doing a lot of Salea stuff. So let's, Salea stuff trying to figure out reliability issues. So I wonder if I could reproduce. Should I reproduce it? I'll just show it. So let me pull up Logic. Hopefully my computer will be okay with all the different things. So I think I could do desktop with overhead if it's still alive, which it is. So what I'm going to do in the Salea is I already have it set up correctly this time for capturing the SPI flash. So you can see here I've got 6 channels that I'm capturing at 500 megasamples per second, and I have a trigger on the yellow channel, channel 12, which is the chip select line. So what I'm going to do is I'm going to start it, and then I'm going to plug it in, and we'll take a look at what it's doing. So I'm just going to plug it in, and the lights flash like CircuitPython. So CircuitPython did start up, which is good news. So let's take a look at what we captured. So I'm going to zoom out. And there's some interesting stuff here. So it starts the capture at the first enable, and that's interesting that there's this like sporadic enable at the start. So the way that did we talk about this? I think we talked about this last week, but it's good to reiterate. So the way that the RP2040 works is these are some spurious clocks, which can be done to just like get the flash logic going. Some more clocks here, but then there's a read. So 03 is the most basic read of a flash chip. Love the factory says, is there a good small library for ingesting UART stuff and parsing into variables in CircuitPython? Not that I know of. Python's usually pretty good for parsing from strings to objects, though. Okay, so what happens at the first is that there's this blank, so it's a read, and then it's 3 bytes of address, 000, so at the start of flash, and then what you get back is the contents of that, and it's a 256 byte read. And if I just zoom out a bit, we'll see kind of like how much we're using. Like, consider this the progress bar for how much we've taken up. So starting here and then at the end here, the last 4 bytes are a checksum. And what this does is it makes sure that it allows the bootloader to verify that it loaded the initialization code correctly. And then the other thing I want to look at is the clock rate here. So in the top right, you'll see that it's a duty cycle of 49.91. This is just for an individual one that I've cycle that I've highlighted. And you can see the frequency here is 938 kilohertz. So what we're doing is we're actually like, it's being very conservative at the start to load that first 256 bytes. But what's going to happen is that as we start up, we're going to see that clock speed accelerate. So if we just look here, so there's a big gap. And this gap is when it's running this first chunk of code. And then once it's reinitialized the flash, what it's doing is it's jumping into CircuitPython. So what these bursts here are is it's a read, 3 bytes of address, and then 4 bytes of data back. So you'll see that there's a bunch of different reads, and this is the way that the SSI works on the RP2040 is that for every word, every 4 bytes, it has to send the address again. And in this configuration, it also has to send the command. And it's all kind of typical SPI process where there's one line sending stuff out and one line sending stuff in. And you can see that channels 11 and 14 are unused. So what I'm going to look for here is, so this is all this traffic here is loading the code to initialize the RP2040 and then CircuitPython. And if we zoom out, let's see if we can find. So the clock rate here, we're still under a megahertz. So let's keep going. So one of the first things that happens as code runs is that clocks get changed and they get initialized. So what I'm looking for here is actually the point that clocks get sped up. And this point is actually really, really interesting because on the Feather RP2040 case, this is where crashes were happening. So what I was doing is I also have the SWD connector on here, and I had my J-Link connected, and I'd find that I would enter a hard fault, but the hard fault wasn't exactly in the same spot. It was in a variety of spots all around clock initialization. And for anyone who's ever brought up a chip, and I've brought up a number of them now with CircuitPython, it's always the clocks. Like whenever you're just getting things going, is getting the clocks configured correctly. So what we're going to see here is, let's take a look at this gap. Now we can see that like our enable line here actually speeds up. It's kind of hard to see on the video maybe, but you can see it's kind of like a solid block here and then not left wise. So let's let's dive into this a little bit more. So here we can see, if we look here, we're still under a megahertz. But now we can see that this gap is getting shorter. So now it's at 2 megahertz. So some clock changed from here to here. And then if we go further right, we can see that, oh, now it's getting way fast. And so if we zoom in and we mouse over here, we'll see that we're actually at 21 megahertz or so, just on that one. And let's actually, there's a measurement thing, so let's actually use that. So how do I add a measurement? Add measurement. There we go. So if I drag from there to there, what that's going to do is it's going to give me an average. So right now it's running at an average of 20.833 megahertz. So I think it's configured to be 20 megahertz, but especially early on, and this is as we plugged in, all of the clocks have to kind of stabilize as things start up. And so there's some variation, and that variation is going to be especially great right at the start. So what I was finding with the reliability stuff for the Feather RP2040 is that it would get maybe eight entries into this kind of fast thing, and then it would just stop. And the reason was that we were basically running too fast. We weren't able to load the correct data from the flash, which means we were getting incorrect instructions into the CPU. And when the CPU got bad instructions, it hard faults and just stops. And so you don't see anything else afterwards when that happens. But so now we're running it slower. And I actually do want to run it at, so there's a divisor in the, Luke points out that 20.833 is exactly 125 divided by 6. So I'm right that clocks take time to warm up, but at this point they already have warmed up. So that is actually exactly the number that we want. So what Luke is getting at is that there's a divider that that produces the clock signal for the SPI flash chip based on the core the core speed. So the core speed is 125 megahertz, and right now in the settings, whatever I just loaded, it's dividing it by 6. And the reason that it wasn't working, or was like half working for some folks, is that it was running at divided by 2, so it was running at 62.5 megahertz, and the flash chips that we used, it's weird because the flash chip that we use is the 8 megabyte giga device one. GCM, hello, arrived late, have been enjoying this RP2040 series. Well, we're in it again today, which is good. Let me find, okay, here. So I have a ton of tabs open, all for different flash chips. And in fact, I have more flash chip tabs in this other window off screen. Let me grab this Giga device one. So this is the flash chip that's on the RP2040 Feather when you buy it. Mine, I think I just put it back in as well. So mine has it as well. And at the bottom of the flash datasheet, there is an interesting section that tells you how fast it can go. And it can go different speeds at for different instructions. So if we look at here, there's serial clock frequency for dual I/O, quad I/O, and quad output at 3.0 volts, which is what we're at without high performance, is 104 megahertz. But right now we're doing a read 03, which puts us down here, and it means it's at 80 megahertz, which actually should be fine for the Feather RP2040 because we should be doing 62.5. But I think what was happening is that I suspect that the clocks weren't getting started, but maybe I haven't actually been able to prove that. But it is possible. The other thing to consider is that, like, I was going to say, I don't know. I don't actually know why the Feather RP2040 would not work for the 8 megabyte case because of this number. It's also possible this number is a lie. That's the other thing to consider. So if you look at the 4 megabyte version, so I just dragged up the 4 megabyte version here, and we go to the same section. What? It's 80 as well? I could have sworn it was 60. All right. We have Luke's attention. We'll ask Luke about this. Luke says you might need to use RXDLY to delay the sampling when running your max flash frequency. I think we are, but I can't remember because I've been doing a lot of different stuff. Yeah. So I think RXDLY we're not using on the generic 3 version. So we could try that. The problem is that because this has a bunch of wires off it, it's actually like not great to test like absolutely top frequency what you can do. Because you have longer wires than you would on a normal PCB. So let's, we can play around with this, but what I found on the 2 is that the max clock frequency, right, the max clock frequency for read 03 is 60. That's what? No, it's 80 for the 4 megabyte 2. I was thinking it was 60. We could play around with that actually. We can see if we can't crank it up. So let's see where I'm at on Dexter says wires, them's antennas. True. Let's pull up, and I don't actually know what version I just loaded, so let's take a look. So right now we're not using my C version. These are just using the assembly versions. And in makefile we have where did it go? Yeah, so there's this flash spy clock divider. So I set it to 4. Let's just see if we can't get 2 going. Let me try it. I was able to reproduce it. So I'm gonna make clean. I gotta sneeze. I have the window open, so it might be sneezes from pollen. All right, cleaned. Let's build. Everything is out of focus. Make sure that your YouTube stream is on the highest setting. It looks okay from here. Okay, we built. And I do have it on a cable with a charge and data line, so if it doesn't work, remind me to do that. Let's just try it real fast. So this other CircuitPy here is the timestamp one. Yeah, RXDLY. But you can't, RXDLY doesn't work if you do divided by 2, right? Because there's no extra clock cycles in between. Hi, Fede2. Okay, so here, look what happened. We copied it over, but CircuitPython didn't come up again. So let's logic it and see what happens. So this is with the -2. So I'm gonna just hit. Actually, I'm gonna flip data off because I don't want USB to really be upset. So I'm going to hold the reset line down. I'm going to hit start on Salea and then lift it, and we'll get a capture. Now the LED is not doing anything, which means things stopped. Okay. Luke says it delays your sampling point to the point in time where you launch the next clock transition. Which will give you plenty of time hold time. Okay, let's try that. So here's what we have so far. This is using the generic assembly from the Pico SDK. So here's what I was talking about, right? So here's the 256 load. Here's all of the initialization code, and then just everything stops. And if we look and look and look and look, we can see that we only made it two cycles in at this frequency. Let's add a measurement and double check our speeds. So we can see here our average is 62.5 megahertz. Now I am doing it with the wires, right? So like it's possible if I load this onto my other Feather, which I could actually do, it might work. But as Luke's talking about, we could also set our example delay 1, and that would cause it to wait longer to read it, I think. So that might fix this issue as well. Because it should be able to, like the data sheet says it should be able to go to 80 megahertz. Of course, that does rely on the PCB layout a bit as well. So let's just try it on this other Feather I have. Luke says, I bet the second read is the hard fault vector fetch. Yeah, that sounds about right. So here I have kind of this is why if you're ever doing debugging, having multiple is great. So I'm just holding boot select as I plug it in. And I'm just going to copy the same binary over. And, oh, I had my data switch flipped. I was like, why isn't it there? So now it shows up. Copy it over. So let's just see if it works. But Luke's saying we should be able to set the sample delay. So we'll see if that fixes it for us. So we restarted and look, it came up. This is funny though, because Todd, who's in the chat, was one of the folks who reported this problem. Is that it's working fine right now, right? But that it went straight from the bootloader to the code, and it must have run the stage 2, but I'm not 100% sure that it did. But if I unplug it now, let's unplug and plug it back in and see if it works. It didn't. Right? So it's on power up that it didn't work. And this is why I was thinking like, and we can, if I hit reset, let's see if it works. It still didn't work. So it's very weird. This is why I suspected a thing of like on power up something happens, that the clock like just doesn't initialize correctly. So now if I power cycle it, it just doesn't work at all. So one thing I was dividing it down to make it slower to make it work. But I'm actually curious now if we can't actually add the sample delay. So I'm going to put this back into... yeah. Let's pull up the assembly. And we can steal the sample delay from the other one. Somebody was like, I love that you do assembly on the stream. So let's do single column view. And then, so here's the fancy one. And there's delay. Here's the baud rate, delay offset. This is funny. There's two different types of stores. So move is like moving this value into a register, and then store is the register back out. And if the offset's low enough, you can do it in one line, but if it's not, you have to do it in 2 lines like this. So we're going to want that. We might need to modify it, and then we'll do it in the generic one. So here's the generic one, and it defaults to 4. This is what I was confused by. Hexbone says, is there a good source to understand how PIO was implemented? It's not part of the M0 platform, right? So I'm assuming it's something uniquely developed for the RP2040. Correct. Yeah, it is unique. The Raspberry Pi folks designed it. It's important to think of like microcontrollers are really what's called a system on a chip. So there's a CPU, and then there's all these peripherals around it, and those peripherals might be from a lot of different people. And I like to think of it in the same way as like if you have like a microcontroller and a bunch of I2C sensors, like it's the same idea, except it's all of those things on a chip that are connected via like a memory bus instead of I2C. Okay, so this is what we're doing here. So there's no delay that's being set. So let's just do that in here. So it looks like R1 should be fine to use. R3 is still the offset, so that should just be fine. So we're going to save that and see if that helps us. And I should be okay to just do that. Actually, like V1. Okay, so we have a new version. I think it's already in bootloader mode. Let me copy it over and see if it starts up. Why did I buzz? But yeah, the data sheet's good. There's a good, I just watched a video on PIO from Stack Smashing. Hey, look, it came up. Although that was from the bootloader, right? That it worked that way last time. Let me show it. So we did get it, so I'm going to unplug it. And in fact, I'm going to switch data lines off. And it still works. Look at that. So it looks like we should be able to run at, let's try it a couple more times. Yeah, that one worked. Neat. Very neat. So we should be able to run it faster. Uh-oh. That time it didn't work. So I think still slowing it down is the safe bet. That's the thing, right? Like if it doesn't work and you crash, you're done. So like something like this where it works most of the time is just not good enough. It's got to work all the time. And yeah, it'll start up slower, but like for speed on a chip, like any chip where you're storing your code off the flash, you're really relying on caching to be performant. So let's just see if I can do it again. Like it's pretty reliable, but I did get it once, right? And like that's enough for me to not want to do it. Does a reset button get different behavior? I think I don't trust it, honestly, because like as you plug and unplug, you're actually like you have timing of like how power goes around and how debug capacitors. I can try. Ah, there was one. So the LED is no longer ramping, and that was just a reset. So it's got to be reliable. So that delay should be fine. We could leave that, although that's in the SDK, so it'll be removed. I'm not going to change the SDK, but it's good to know. But it's this clock divider. It's got to be 2, or it's got to be 4. It needs to be reliable. I need some kind of hardware test bench. Yeah, I mean, I'm a software person. I I definitely like bridge that gap, but like that's something the Raspberry Pi folks I'm sure have is ways of checking all this stuff. Okay, so I just built a new version, and I'm gonna. Ooh. Let's see. Let's copy. So this disappeared because I cleaned it. So I just gotta back out. Hello.
Wow. That's weird. You're not appearing, but maybe that's okay.
I mean, I don't think I normally appear to you on Discord, right?
No, but usually I see like a thingy, a thinger.
Oh, like my icon or something?
Yeah, it's a technical term. Am I up though? I don't know.
Yeah, you're up. You're
Okay, great.
Folks can see and hear you, I think. People can confirm they can hear you, but they should be able to.
All right. Well, I thought I'd stop by. I know you're doing more Flash. I don't have a ton of new... Huh?
I said I know Flash. Luke was in the chat for a bit at least and was helping out.
Oh, that's great. That's cool.
Yeah.
I got some prototypes, so I can just quickly show those off. I mean, like they're not. I literally just got them this morning.
Yeah.
So I can just show those off, and then maybe by desk LadyAda I'll have 1 or 2 assembled.
Cool.
So I got these. Comes in this plastic wrap. I get my prototypes from Gold Phoenix sometimes because they will do weird routed PCBs, which I kind of like. So this is the ItsyBitsy. So let's see if I can get that to focus in on. I can do it. I cannot do it.
You need one of these Sonys.
I know. Well,
they're great for
I could get the I mean I could set up the overhead. Well, yeah, it's funny. It always like works when I don't expect it, and then doesn't work. Well, whatever. But anyways, you can kind of see how big it is. So it's
there you go.
Yeah, here you go. So it's the ItsyBitsy RP2040. So you can see I've got the big flash chip.
Yep.
On the right.
Right, the 4x4.
So I made room for that. Yeah, that's a 4x4 WSON. And then I've got a lot of 0402 resistors and capacitors. So all the non-large caps. So like the 0.1 microfarad and the 10K resistors and the 22 picofarad. Those are all 0402s. So I could keep the 10 microfarads 0805s, and then the 1 microfarads are 0603s. And that's because capacitance is affected by the size of the there's a derating that occurs, and so you do want to literally have the physically the largest size you can get. With the capacitor, you'll get better DC capacitance, because otherwise it derates. 10 microfarad turns into a 1 or even less. Like it derates quite a bit. And then on the back we've got some nice silk screen, which who knows, maybe it'll show up, maybe not. But we got this. I don't know. I'm so cursed. We got this nice circle, and then on the bottom. We got the RP2040 logo. So that's cool. Raspberry Pi. It does show. You can see the Pi. Yep. And then on the bottom, we have the GPIO pins labeled. So on the top, we have like the standard ItsyBitsy pin, so that like all our Itsy wings and stuff will fit, and also people can like plug and play. But then on the bottom, you get the GPIO pins. And so it's just a ton of pins. Like you just get a lot. And it has the SWD pins broken out to headers. So if you want to solder headers on, but it's just very, very small and very cute. And we were chatting earlier today. I actually can't find 8 megabyte 4x4 WSON chips. Like there are none. I got like the last 40 from Arrow. Right. So until I get more, I think I'm probably going to launch this board with 4 megabyte. And then I said, is that okay? And we can upgrade to 8. And he said, yeah, we can do that. So then you have a project to do, which is how do you support 2 different chip families, because it'll probably be gigadevice 4 megabytes to start, and then it will be 8 megabyte winbond later.
Right. I'll have to consult my table. My table of all the flash chip
Cool.
info. I did talk to Luke briefly about the SFDP stuff, and he said that he actually like bought 10 random
Oh,
chips off of digikey and like had varied success with how well they were implemented.
uh,
So I think the
executing place
approach,
is hard.
yeah, yeah, it is, and yeah, there's like a sample delay that you can do with it as well, and he recommended doing that. That's what we were just doing, and like most of the time at 62.5 megahertz it works, but like occasionally I could get it where it didn't. So I think we're still gonna have to run it like 30. I think it's 30
For generic O3 or
for generic O3, but
I
we'll have
think
to
you know
see
what?
for quad still.
I think generic O3, look, it's generic O3. It's generic. It's SPI. It's slow, whatever. And
Right.
then if Alistair, they're chatting about it. How do you support boards? Because there's not a lot of people making boards right now because you can't get chips, but
Yep.
that's going to change.
Right.
And they're going to have to come up with a story. How are they going to make development easy for people? So I think having having it. If Scott, if you come up with something that can support like 2 or 3 different families, they will probably use it. The more,
Right.
it doesn't matter as long as they get activated in QSPI mode. So
Right. And I think
lots hanging on your,
I'm definitely looking at it. I glanced at like just buying a bunch of chips off DigiKey as well, but I don't think I want to go that far.
Yeah.
Yeah, it's tricky. Like, also there's max megahertz that you can run it, and it depends on the routing as well. Some.
I'll say I don't think
Yeah.
the routing. I know that I shouldn't say this, but the routing doesn't matter as much as you think. I think that the variation you're seeing on some chips, it's really just at edge manufacturing of the chip itself, because the wires are so short that yes, 60 megahertz is fast, but like I have the Pi TFT, right, which is I was showing it earlier, connected to the Raspberry Pi 400 like this,
Right.
Okay, so this is like a nightmare. You know what I mean? Like I take the SPI pins and they're routed through here, right? And then they're
Right.
routed through here. And there's no like differential pair. There's SPI just routed. And then we run the display at 80 megahertz. And it works. So like if you're not on a solderless breadboard, I mean, like, yeah, you're just supposed to like do the right things, but you can get away with a lot. I don't think it's the wires.
Okay.
People are always very like neurotic about it. And
Yeah.
there are some situations where I'm like, the routing really does matter.
Yep.
I don't actually think that's it. I think we just really are just running the chip over past its clock rate, and it actually really does that limit isn't like a soft limit, it's a hard limit. They really mean it. Like really doesn't work.
Right, but I was looking at whether the data sheet's a lie or not is a separate question, but like
Yeah.
I went back and looked at both the 4 and the 8 giga devices, and they say they could do O3 at 80 megahertz tops. And I'm only doing 62.5, and I'm still seeing some reliability issues with it.
Yeah, I mean, it could be the drive strength. Could be. I mean, it's tough because the moment you put your scope probe on it, you're just adding picofarad capacitance, and that's going to be affecting it.
Right.
Yeah, it could be that resistance, adding an inline resistor could help. But it could be other things. It could be the peripheral. The peripheral has some, minimum setup time for latching, and that could be there could be a couple things. It's not saying it's not the traces, but I think that a lot of electrical engineers kind of like blame the traces first, and it can be a lot of things.
Yeah.
And we don't know what the problem is yet.
Right. And you know what? Like, I think my point as the software person in this equation was like, if our software is designed well enough, it doesn't matter, right? Like, whenever you're getting your code from SpyFlash, you really don't want to be getting it from SpyFlash. Like, you want to rely on the cache, you want to rely on the RAM, and like to get it in there originally, you have to worry about it. But after that, it should be nice and quick.
Yeah.
So I think that, I think we have to pick settings that are just reliable, because that's what matters most. And then what I haven't shown yet, but if you look at the SPI traces when CircuitPython is running, you can see little spikes where it's doing fetches. And like we could get rid of those little spikes because we could just add more stuff into RAM, which then frees up the cache, right? So like there's software solutions around like I want to be able to do this thing quickly.
If you want to do good software, learn to make your own hardware, right?
100%. Yeah.
As a wise man said. I think that there's a lot to be said there. I'll say another thing, and I'm making a lot of assumptions based off of the SAMD 21 and 51, but what's interesting about those chipsets is that the SPI peripheral really was limited, like very, very limited. The max SPI rate on the SAMD series was 12 megahertz, which is just ridiculous, right? For something that's running at 120 and can easily overclock to 200, you were still limited on the SPI at 12 megahertz, and it really was limited. That was it. Like you really could not clock it any faster. We tried, if you can clock the output at 24, but the input doesn't work at 24. Right. And it's not a trace thing. It's just the setup time. The circuitry just couldn't get the data in time, to get in the peripheral. But then, if you switch over to QSPI mode, right, which you'd think like, ooh, like that must be much more limited or whatever. It actually, then you could blast it at 60 megahertz or even 100. I think we did. We double clocked it and it worked. Like you could really, like not only is QSPI 4 times faster, but the peripheral itself can handle the data much, much faster. Right. And like I'm not sure the full details of it, but there's definitely something about like these chips in SPI mode and like ARM Cortex chips. Like I know I'm like generalizing, but the SPI mode really should be just to get it booted, and then you immediately blast it into QSPI mode as quickly as possible. I think, we do that in CircuitPython. Like we are so like QSPI, like the moment we can do it, we move immediately.
Yeah, and in fact, I was showing that I did a Salea trace earlier where I was like, look, here's where we're fetching from the flash at 2 megahertz. Here's where we're at 6 megahertz, and now here's like, it's funny because we've been talking about this stage 2 stuff, but like the stage 2 stuff runs when all the clocks are actually still slow. So it's like you get everything set up, and then like as you start up. And this is why like the 4 megabyte was crashing, is that like as you start CircuitPython, it's in the STK code that's initializing the clocks. And the moment that you switch to the like high speed sys clock for your QSPI peripheral, like you end up going really fast. And if you can't, like if it's configured to be too fast, you'll like randomly hard fault at that point.
Yeah, and I want to argue that again, traces not traces. The fact that the 8 megabyte worked fine and the 4 megabyte didn't, even at the same clock rate, and they're both rated to run at faster than 60 megahertz means it's not the traces, most likely.
Right.
You know what I mean? Like, if it really was, I mean, and you have like wires hanging out into a socket, right?
I do.
You performed like open heart surgery on this thing too, right?
But I do have an unmodified one as well that I'm comparing against.
Are the data sheets lying? I don't know if they're lying, but I think that there could be, there's always like little weird exceptions. Another thing is, I was saying about how like, you can run these TFT screens. Like the ILI 9341 is technically specified at 12 megahertz, but like we run it at 80 megahertz, and it's like, woohoo! Like sure, go ahead. Sometimes like it can do it, but it doesn't like the commands to be run at 8 megahertz. Like when you do the initialization, it's not a delay thing. Right. The commands we send at 1 megahertz. We I think even on the Raspberry Pi we try to go down to 1 megahertz. Right. To send those initialization just to get the gamma table and whatever. But then once we put it into address mode, like you basically set up the window address of the thing, and then you just blast pixels at 80 megahertz. And that's fine, but the initialization has to be slower, even though you're like, that doesn't make any sense. It's the same peripheral. It does matter, and it's not a delay thing. Right. If we add more delays, it doesn't make a difference. It's like
the control circuitry of the display just can't go that fast.
Yeah, it's very weird. It's just like it really doesn't logically make any sense. But it doesn't. So I'm not worried about it. I know you'll figure it out. Yeah. And
well, so Luke
Luke
did just give another tip. because the
Yeah.
RP2040 has input Schmidt triggers
Mm.
for the inputs. And so basically there's two versions of the flash setup code that we use, right? There's the
Yeah.
W25Q80 that does the like quad SPI stuff, and then there's this generic one. And the generic one is what the Pico uses and why people haven't really seen issues. And now we're starting to see them as we get new designs. Like we switched to the generic one because we didn't know what flash we were going to use, and that's like work on any flash sort of setup. But the other
No, we didn't know what flash we were going to use, and it didn't work. And it didn't work with the W25Q90. Believe me, I tried, and it didn't work, and that's why we switched. But yeah,
right. But that was also quad enable, right? Like we came down to the quad enable's different than that one. It's a whole other thing, right? Like I put the chip on and it worked, and it didn't work for you. But yeah, so this.
Oh, because the quad enable was prefixed, and that was actually a decision that Scott and I, we had this discussion this week for folks. Did you tell people about the quad enable bit being non-volatile?
No, go ahead and recap that conversation.
Okay, so we're like, may the people who designed this like burn in hell, because they made the quad enable bit non-volatile, which means that if you successfully set the quad enable bit once, you never have to set it again.
Right.
Which I understand, but it's also, I feel like there's no other status bits that are non-volatile that I know of. I think like that's the only one.
There's protection bits as well. And you can actually
that
write...
makes sense, though.
Those
should be non-volatile.
You can write in a volatile way if you want to, I think. I think you can actually do a volatile write to some of them. I don't know if that's something that all SPI flashes allow, but it would be possible to do that.
So the thing is, if you have a flash chip, which you're like, Scott, you're like, I'm going to I'll desolder this flash chip. Oh, I don't have one. I'll desolder off one from a prototype of a Pi portal. And he's like, it works for me.
Yep.
And I'm taking a fresh chip off a reel, and I'm like, well, it's not working for me.
Yep.
And then I'm like freaking out because I'm like, why isn't it working? It's because the Pi port, we set the bit in a non-volatile way in CircuitPython.
Yep.
Because why not, right? It doesn't matter to us. But that means if you're recycling a chip, it works because it has that bit already set. Whereas if you have a fresh chip, it doesn't. And I just feel like, why would you do such a thing? So we actually had the discussion of whether we should make their testers set the non-volatile quad enable bit.
Right.
You know what I mean? So it's like we set the bit, and then we don't have to deal with this bullshit in the second stage boot, right? We just
100%.
It's already been done because we manufacture it.
Right.
And I actually said I don't want to do that. And the reason I didn't want to do that is it's a very, in my opinion, generous. Most people would not call me generous, but that's okay.
I think it's generous.
I didn't want people to DIY their own versions of our boards and then wonder why they don't work.
Right.
Like, I didn't want people who are like, oh, I'm hacking my own boards, or I'm like modifying, and then they're getting a fresh flash chip and they're like, I don't understand why the quad enable.
Right.
It's like because it's not like it works slowly. It like doesn't work at all. Like your board just doesn't boot, and it's really confusing.
Yeah.
Especially because it burns correctly. Like UF2 doesn't error out.
Right.
UF2 like happily,
because it's not doing quad stuff.
It's not doing quad, so it shows up under USB with the UF2 bootloader. You drag the file over, and then you hit reboot, and it's just like dead in the water, like nothing.
Yeah.
Because it's like holding on this thing. So I was like, even though it would make our manufacturing and coding life easier, I just thought like, the 10 people who are going to bump into this, it's just not it. I'd rather do it and do it right, because I feel like we would have to go back and do it. So this was a design decision we made, right? Like we could do a shortcut, and we decided not to do the shortcut, which is why Scott is suffering with you today.
I don't mind it though. It's okay. I think we're going to be in a better place. Like one of the goals with all this work is, well, I'm on a detour right now, just making it reliable, right? But getting back to the getting all the stage 2 stuff for CircuitPython set up is like, if we can get to a world where we have a set of 6 flash chips that we say any of these will work, right? And they're different sizes, but they all quad enable the same way, basically, is that and they have the megahertz limits and stuff. But if we could say here's 6 different chips and you can pick which one you want, we started doing this, here's a spot for SPI flash on the QDPI, for example, right? Like
I think that if we tell people, look for CircuitPython, I think in general, I mean, yes, there's like a Desto and there's like Maxtronics and there's Cypress, but like really there's only a few flash chips that people in our community tend to use.
right.
And that's because they're the 3-volt safe ones and they're low cost. And they're like stocked by like DigiKey and other vendors. And like I use GigaDevice because WinBond isn't not always in stock, and GigaDevice is like it's very affordable, to be honest. Like you can get GigaDevice chips for under $1. So I think it's okay if we don't support all of them, but and I think if you can even prep Scott through like all of our board definitions for other chips, like SAM51 based ones, and you'll just see what chips they use.
Yep.
And then it'll be like, here's the top 3, families, and that's that. Yeah, I mean, I wish there was a universal way, but I think that's kind of the best thing we can do. And then, hopefully, if the Pico SDK, I know it'll slow things down a lot to move back to generic 03, but I think that long term, there's just going to be, it's such a confusion is the reason. You know what I mean? It's like
optimizing for power use, right? Like, don't think about power use until you can measure it. And the same thing is true for like worrying about how fast your SPI flash is. Like the default setting should be super reliable and just get you going regardless what chip you are. Like that's what O3 should do. O3 should be slow and reliable and get you going. And then once you care about performance, now you can get a Salea on it and you can take a look at what you're doing. You can really push those boundaries.
And you can do stuff like RAM caching, like you mentioned. Like you can start configuring. Like there's a lot of stuff. Right. Like look, even hitting QSPI is going to be way slower than hitting RAM.
100%.
Like,
yep.
You're like going off disk. Like you're going to the woods. So anything that you want to do with optimizations, I think. Yeah, XIP has this issue. I mean, it's totally solvable.
Yeah.
This is the tough part, right? Decisions have to be made about like. What are the trade-offs you want to make for usability and performance? I get it because people like you have a trade-off of either people saying, I put together this board and the default code that I compile on Pico SDK doesn't work, right? Which is bad.
Right.
And then you have the alternative, which is people saying, well, I compiled this code and it ran, but it's like, it's so slow. The chip sucks. Like you kind of have like jerks on either side. Like,
yeah, that's what codes of conduct are for.
Jerks, but like, people having struggles, and they can get pretty snarky about it, and you want to make sure they have a good experience. How do you balance that?
Mm-hmm. Yeah, I think it's tough. I think having the default be slow and reliable is the way to go. Like, and that's why
that's always been your thing. That's like your T-shirt.
It is my T-shirt.
Yeah.
Yeah, I mean that's where I want to get CircuitPython is like I should stop worrying about how fast I can get generic 03 going, and I should just like get it super solid. I think I just committed it as divided by 6, but I think we could do divided by 4 and still be super reliable. So like
wonderful. Beta 5 has a 20% speed up.
I know, right? So I was actually looking at one thing that's really interesting to me as well is dual data rate. Because that means all your clocks you're getting twice the data for the same clock.
It's like what samples on rise and lower?
Yeah, yep.
And the chip has support for that natively?
So yeah, the RP2040 chip does, and some of the flash chips do. I'll have to look at it again.
Yeah, I mean, like, sure. It's like, why not? You get twice. I mean, that you still... If your peripheral can handle pushing the data, there's no reason why not. I mean, you still have to watch for your setup, your data setup time, but at worst you just run it a little bit slow. I mean, you have more flexibility in the clock divider because I know you're like, you can't like set the clock to be 44 megahertz. It's like 40, 60, 80, right? There's going to be just like some even dividers, so you might have more flexibility if you do dual. I don't know, why are they so different? I don't know.
I don't know. I think it is interesting. I just thinking about it, I wonder if it's also like lifetime of SKUs, right? Like people build a product with a flash and then they want that same flash for 10 years, right? Like,
oh yeah.
And so you get this like the 2 megabyte GD is like different status registers, but the 4 megabytes different because they like have different generations, all within the same family.
Yeah, I don't understand. I really think that's a crime. I understand the protection bits are going to be different because maybe you have more data you want to protect. But like, goodness, why are you changing the status register? Like, what benefit? Like, why would you do that just because the flash is larger? Like, really?
I don't know why they moved to it, but the winbonds allow you to do both. Like, either you can send like one status write and then give like 2 bytes for 2 bytes of status register, or like the new ones you give it a different command and go straight to the second byte.
I did see that. It's like OX51 and then OX55 and then OX15. Like, it's a little bit of a hack. They kind of like, they're like, well, you know.
Well, the thing that,
your way into the
digging around the winbond stuff, the thing that blew my mind is they actually had 2 different versions of like the data sheets for the same exact SKU. They have the like DTR ones and then the non-DTR ones, which got me thinking about this like generational thing of like, they have the previous version that didn't do all the fancy DTR, but now all the chips do that, but they're backwards compatible. So like you have the old data sheet for the previous ones, but all the new ones are new, and like they just replace them. And the only way to tell is to actually like read some register on the flash itself.
Yeah. It's fascinating to me that this conversation, it's like we're just going to hear this conversation a lot, but in like 2-3 months when everyone, like, it's like, this is a preview for what everybody, this is like the trailer.
Yeah.
This is going to, I think it's going to not be shocking, but it will definitely, I think it's going to be an issue. I mean, as people have to, you know, they have to load this custom thing, and this is one of the trade-offs of having external memory, and it's such an unusual thing. Most boards do not have external memory, and only like the IMX do, and because that's why we happen to be like, we already got like a preview of this, like the prequel, when we started doing the IMX, because again, that quad enable bit was non-volatile. Yours worked, mine didn't. Somebody's did, I don't know. Like the bootloader didn't set it.
And we saw it with SAMD51 as well. Like SAMD51 had QSPI just for the external flash that we could do.
That was our preview, but at least there it was like, you know, the code was running. Like it would enumerate the USB, 100%. Just wouldn't show up as a mass storage. So we're like, okay, we know something's going on. Yeah,
you don't get random
we're getting
hard
good
faults.
At it, so.
Yeah, the random hard faults was like, I was doing GDB and it was like, oh, I'm in the clock configuration code, but it's not always the same place. And if I look at like the instruction, it was like, maybe it was like finally like I called disassemble and it was like invalid instruction. And I was like, oh, like it's not able, like it's not correctly loading off the flash for all this stuff.
Yeah.
So yeah, we're getting through it.
Okay.
It's well worth the effort, right? Like I think CircuitPython is well positioned to be very board friendly on the RP2040 boards. You know, like somebody asked about MicroPython support for the Feather RP2040, and I just went like, I have this issue open with MicroPython, but I don't know what their plan is.
Yeah, I should add that to like the product page, because I didn't even, you know, test it, because it's like, it's going to be so different. And honestly, there should be a different build for each board, because not all the pins are exposed, and like it should throw a fault if you don't, you know, it should not let you use a pin that doesn't exist, which is different, managed differently.
You know, that's something we've been really sticklers about, making sure that our experience is the same across all our ports. And so like when it comes to doing a new port, of course we have a boards directory, because we have a boards directory for all of the other ports.
Yes, we have to think about, you know, I mean, I think what we might ask is MicroPython, can you just make a generic 03 build, or can you make a winbond build? You know, I think, but definitely as people start making different sized flash memory chips, I think MicroPython just have to know about them. It needs
they could do it for other boards, right? Like, or other ports, right? Like this is not new for them. But then again, I don't think there's a whole lot.
That's right, because I made a Feather definition for the Feather STM32F405.
Right.
And I did make, you know, you configure with a PW, like you kind of have to like pre-configure the PWMs and stuff, and the I2C peripherals. So I think we did do that. So it should be possible.
Yeah. But I think we're well positioned, and there's not a whole lot that you can do with MicroPython that you can't do with CircuitPython, right? Like the only major thing that I'm aware of, like the PIO stuff is kind of all settled out, and we have some really good stuff. Like Jeff did some mods on that, and then like the only thing is like using the second core. Like if you absolutely need that clock speed or that like CPU time for the second core, like CircuitPython doesn't have that. But besides that, like I mean, obviously I'm biased and you're biased too, but like, I just want to tell people like
I'm biased, but I like to have options.
Yeah. And it's good for customers to have options, right? Like,
yeah, because we sell the hard look. I mean, people. It's funny. It's people are like, you only do CircuitPython. It's like, no, actually, I do. Most of my time is in Arduino. Like, I still write an Arduino library and board support for every board we do.
Right.
Pretty much. Like, very few boards don't have Arduino support, and usually it's for a very good reason. But we still, we do tons of development in Arduino, and eventually when the RP2040 gets ported over to Arduino IDE, we will submit a board definition, or we'll have a board definition package for it. Yep. Absolutely.
Yeah. I mean, it makes sense, right? Like, you sell hardware, not software.
Well, I mean, like, there's sometimes people, I get it. Like, there's some situations where I really want to have Arduino run. There's existing code you want to run, or there's some like cool thing like an emulator, and you really do need that speed. I still think CircuitPython's a lot more fun, but there are situations where where Arduino has its place.
Like tacted board definitions for the Pico SDK already for our boards as well, right?
Yeah, it's so nice. Thank you so much, Dad.
We should double check that because I think
2 hours.
I think you might have been too aggressive in the flash speed. On some of those as well.
Well, we don't. I mean, I think we'd have to. It doesn't even work because the board definition is using the generic. We didn't specify a different flash chip.
Oh, you know what they could do though?
So it wouldn't.
They could load CircuitPython. No. CircuitPython's generic right now, but once we have quad enable on CircuitPython working, you can load CircuitPython to set quad enable and then use the SDK.
See, this is exactly what I'm talking about not doing. Okay. And with that, I'm going to go. Thank you,
cool, thanks
everybody,
for hanging out.
Me.
Yeah.
I'll be on Desk of LadyAda on Sunday. I've got some fun keyboard things. This is my little keyboard thingy.
Nice.
So trying out these Kale switches. Yeah, I got the prototypes. Of course, I put the NeoPixel on backwards. I didn't reverse mount it correctly, so like. Will eventually show up, but I had to rewire the NeoPixel.
Nice.
So you can see like every wire is redone so that it's pointing out the front.
Awesome.
But I've got the Kale socket and
on the back, right?
Little pin out. So yeah, so you can see that it's flat.
Neat.
This is flat, and then the socket switch sockets in. So it's like that.
Cool.
And then you can customize it. So it's like, hello, look, switch comes out. So yeah, actually, I'm ordering the PCBs because other than the NeoPixel being flipped in like a little dimension thing, it pretty much just works. And so I was going to just order the PCBs, and then we can start making keyboard prototype type thing. I'd like to do the breakout first.
Yeah,
that's Desk of LadyAda. So come by. I might also have the Featherwing and maybe some of these other prototypes.
Super
ready
exciting.
To go. To show off.
Well, thanks again for stopping by. I'll handle any questions that came up as we were chatting, but somebody pointed out like it's really cool to see like us have a technical conversation, and it's actually great for us as well because we don't always get the time to have these technical chats anyway. So yeah, no, I mean I'm happy to chat. We have meetings, of course, but this is like the deep dive. So this is when I get to deep dive. I usually don't even go into this kind of detail. 100%.
Okay. All right. Thanks, everybody. Have a great Friday. Go outside if it's warm outside. And don't forget to set your clocks back on Sunday.
Say hi to Phil for me and have a good weekend.
All right. Bye, everybody.
Bye. All right. Yeah, we can chat forever. That is why we're if we're late to the CircuitPython weekly meeting, it's usually because we're like chatting too much. Yeah, I think so. I'm going to go back and look at questions. David G says, does this relate to QT Py Flash? Yeah, it does. relate to like how we initialize stuff. TMZT says, so is there a volatile QSPI enable? I think there is, but we're not using it. Let me look at what they link to. So they link to the settings for the Feather RP2040. TMZT, it's incorrect. It needs to be fixed. It should be 8 and not 4. We were thinking 4 at the very start, and then we couldn't get the 4 going because of the speed stuff. So, so I want to try the Schmidt thing. We got about 20 minutes left, so I think that's what we'll try on this 03. Mark asked, what's LadyAda's view of debug-edge? Probably to ask her. I think generally, like somebody pointed out later, like the edges are usually pretty full. So I'm not sure that's the right thing. The thing she does for me is put the 2x5 surface mount on there. And Lasertronics is still wanting me to get a raise. Yeah, liked the technical meeting aspect of it. Gordy asked, can MicroPython libraries work on CircuitPython? Generally, no. Not without some work. It depends on what they use, what APIs they use. If they use like I2C or SPI, they'll need to be switched over. Because those APIs are different. If it's a library that somehow like uses only standard Python stuff that both of us have, then they will. But yeah. Okay, so let's since we're in these weeds, let's just I want to try the Schmidt Trigger thing that Luke suggested. So where is that? That's in here. So I think we can just snag all of this. So this will let us jam everything out. I have a pretty good understanding of what all this is doing because I have tried to convert it to C, so I kind of know what it is. So let's just give that a shot, and we'll set it back to the 2 to just see if we can get it, if it's reliable with it. I'd just be curious. And let's clean it again. Oh, I did notice that, oh. Instruction not supported in thumb 16 mode. Weird. Why is that? This is in thumb. Thumb function. Is this other one not thumb? So thumb function. Syntax unified. I wonder if that doesn't have a unified syntax thing, so I wonder if that's it. So thumb is type of encoding for ARM stuff. Hybotics asks, how do you get those cool colors and such in your terminal prompt? It's I run fish and then I use a thing called oh my fish to do it. Let's try it again. Oh, and yeah, it was Papa Romeo Mike. Papa Romeo. Phil was asking how I'm building so quickly. I am on a AMD 5950X. All right, well, it doesn't like me. I don't know why it's not working. Cannot honor width suffix. Like, I'm just copying it from here to here. type. Maybe I'm missing something. Frame format. I don't know. I don't know. Oh, you know what I bet it is? I don't think I'm importing, or I'm not including the GPIO stuff. I think I need to do this. That would explain it. Maybe. More power, baby. Notice the -J32. Exactly. I was very excited. Very excited to actually be able to snag one of these. I was like, there was a guy who's streaming on YouTube about when... I don't know why it's not working. I'm going to give up. I don't care. I think I just want to switch it back to 4. I switched it to 6 and it was working for folks, but if it's so close on divided by 2, I think we do actually want just 4. So don't give up. I'm giving up. I don't know why. I want to move to C anyway. I'm probably missing the syntax unified. I thought I added it though. Did I not? I added it and it still didn't work. It was still complaining at me. Cannot honor width suffix. Extra comma 0. Is there an extra thing I didn't copy over? M0 plus. Oh, this doesn't have the plus. Is that why? Plus. The rest of that file will not build unified syntax. Oh, okay. So that's the problem. Don't you love it that I'm user testing for you, Luke? All right, I don't want to do that. I want to move us to C anyway. Even if the SDK doesn't move to C, I'd really like to do C with, like, I think I'm just going to do templates. Oh, on the Bix. I'm going to leave this as an exercise to the viewer if you want to see if the Schmidt Trigger stuff fixes it. Okay, I just, like, I want to be safe with it. That's why I want to do 4. It's actually 6 right now, so I want to set it back to 4. Well, right now it's 2, so let's make it 4. And actually, 10 minutes. I wonder if I can... I do want to move some code. Like, I want all the VM code to actually live in RAM always. Because, so there's 16K of cache, and that's super helpful, but that's super helpful for the code that you don't know you're always going to need. But it's CircuitPython. We know you're going to be in, like, this loop running the VM code. So it's... I would rather just like shove all the VM's code in RAM and make the heap smaller in exchange for allowing that 16K of like dynamic cache to be for the things that we really don't know whether you're going to use it or not. Which is a policy that on the IMX we do as well. But the IMX is cool because it actually has core coupled memory. So it's memory that runs at the speed of the core, which you may, like, I assume RAM in this case is also running at the speed of the core on the RP2040, but the core is only 125 megahertz. Whereas on the IMX-RT, the cores go like 500 or 600 megahertz. So there's even like a cost, like a clock cost to just going outside of, like going to normal RAM. And then they have core coupled RAM as well. And so like we put all the VM stuff in that core coupled memory. Because if we were to sell a product with the IMX-RT, which I actually have, I found my prototype. I have a prototype Metro with IMX. If the selling point is 500 megahertz, you actually want to be able to run, like take advantage of that 500 megahertz. So there is like CircuitPython's going to be going to this tiered memory model anyway. And in fact, we do, the ESP32S2 is another example of that because they also use external flash to store code. Okay, let's do one final check with this. But I don't want to change the SDK. So I'm actually going to check out the SDK. So this still has the RX delay to it. And some other stuff. And I'm going to remove that RX delay because I don't want to change it. Here's my debugging for, I was actually setting a pin high for when the clocks were being in it. So I'm just going to check everything out. And let's do one final test build at 4 divided by 4 instead of the conservative by 6 that I just checked in. And I just remembered I still haven't done my email. So I should do that as well. All right, so we'll build. And let's see, my flips to data. I am. If folks have questions, feel free to ask them. Fish shell. Yeah, I really like fish shell. It does more completion than bash, which is great. So many, I get so many spam calls now. Copy here. Okie doke. Mr. Certainly says, did you get the Pomona clip working from last week? Yes, I did. And the thing that I messed up was there's 2 separate plugs at the end of it, and they were reversed. That was my problem with the clip. That's why I was all confused. Is they were swapped, and that meant all the colors were wrong. So I didn't have the right things enabled and stuff. So it was a bummer. Okay, CircuitPy came up here, so I'm gonna unplug and just do that. Oh, I'll show you the overhead. It's because I'm so popular now? What? You are too wide? Too wide about what? Okay, so we're just gonna, so that one test up. What are you not allowed to test? Tell us. At this point, there's not a lot. It's pretty rare for me to not be able to just talk about what I'm doing. Oh, all the prank calls are because I'm popular. I see. The RP2040, I knew it because of I got early access, so that was like an example of something I couldn't talk about. I got that for the SAMD50 one as well. This is me just being rigorous about it. Occasionally, if like Lamore is brainstorming a product she doesn't know she's gonna release, I won't say it either. But that's usually like pretty early. Oh, the compiler would not honor my width. The compiler, it just doesn't like me. Okay, this seems to be okay. So I'm gonna just do another quick PR just to make it a bit faster again. This should be still conservative. It still should be like, you know, 30 megahertz or so, which should be well under the limits of any of it. David G, if you want, you can't be so engaged in Adafruit land if you don't want to know what's in the Ada box. It's always a lot of tips. Sean asks, is that 2x5 SWD header difficult to solder on? So I would highly, highly, highly recommend picking up these. Oh, you can't see it. These 2x5s. This is a 2x5 where it doesn't have the shroud around it. It's like, it's known as like a keyed 2x5. And we saw these on the NRF dev kits, and I was like, Lamore, we have to get these because it means that like there's not a huge chunk of plastic around it. And the other thing, if you're soldering, so I hand solder a lot of stuff, right? So the way that I was doing it is I start on the sides because the sides of the pins are kind of like easy to access. So like tack it down with like one of the outside ones, and then kind of it's pretty challenging on here because there's like components. The things you have to worry about melting are like the neopixel. You could like melt the plastic a little bit. But if you happen to nudge like any of these capacitors or anything, you're probably fine. But yeah, I would do the two outside, and then just doing the two middle are kind of just like getting in there. So they do take some skills. They do take some practice. But they're super handy. So there's the link. Thank you, Patrick, for the link to those. Gareth asks, how many times is a decent test for reliability in this sort of case? Well, it's not super critical that I get it right because the way, like, I'll do a pull request, we'll merge it in, we'll get artifacts, we'll have people test it, and like, it won't even make it. It might end up in a beta. But yeah, basically there's stages past me just doing what I did to test it. So like, my testing doesn't have to be perfect. And in fact, I will never be able to test everything perfectly. We do rely on our community to test stuff. So, okay, so let's do a pull request. And I think I'll call it, well, let's do a rebase. Get diff. Speed up a bit more. And I gotta grab my signing key. Yeah, they're super handy. I just ordered like 10. Of course, I'm. Oh yeah, desktop. Thank you. I'm lucky. I can just order stuff from Adafruit, but I don't know a lot of great places to find these particular 2x5s. So, it is what it is. Okay, git fetch Adafruit. So I'm gonna rebase this just on top of. The merged commit that has it. So I'll switch branches and I'm going to call it raise default flash speed. Rebasing is really handy before you make a PR. After you make a PR, I don't think you should rebase because the comments of a PR are associated with particular commits, and when you rebase, you are actually rewriting commits. But let me just show how. So git rebase -i. So I'm in the branch that has my change that I want, and then I rebase I Adafruit main. Jim says my card is full, so I can't push it anymore. And you can see here it has just that one commit. So I can say X, and now I'm rebased. And oh, that's weird that it looks like the IDF was updated, and that must have been submodule init, and just do that. That will make me green again. Now I can get push, tan newt to raise. Jeff was so quick on the draw that just got it merged in. Yeah, just to say, Dell, Microsoft, IRS, FDA will never call you directly, and good scammers reverse look up your phone, get your name and address. Essentially, literally, do not trust any unsolicited call, no matter how much they seem legit. Like, if you have a bank issue, call the bank. Don't let them call you. If they get angry or intimidate you, etc., then they totally aren't legit. Yeah. If you question their legitimacy and they get angry, that's the sign that they're not legit. Okay, we pushed. And let me cycle through all the Firefox windows I have open. I'll have Jeff review this too. This is the Goldilocks of speeds. It's too fast. Slower than needed. To be visible by 2. All right. Create pull request. Ooh, I'm getting ready for a snack. Any other questions? It's 4 o'clock. Next week will be a bit shorter because I have to take Spook to the vet, but it should start at the same time. Python script checking for stock for a few days. I do kind of leave stuff in my Adafruit cart too, because I don't necessarily know when I'm going to do a new order. Emmett Ray says, why are you using Mac and why not Linux? I'm on Linux. I was using Mac for a long time, but I switched to Linux largely because I switched to my desktop. And I'm not about to pay for a Mac desktop. No, sir. I use Arch Linux, which is my favorite Linux distribution. I always have the latest and greatest. TMZT says, first time catching it live. I've been watching them since January 29th one. Way cooler this way. Thank you for not only watching, but dropping in the chat as well. Okay, so if folks want to try it, we should hopefully get a new beta out next week. We've just been changing a lot of stuff. So it's about time to do a beta. We'll do one next week. Mototimo has another question. So what do you use to capture the camera feeds? So I have, the other reason I got a new motherboard and CPU is because this motherboard has better USB. So the Sony camera goes into a Magewell, and then that Magewell goes into USB into the computer. The hover cam is USB straight to the computer, and the Salea as well, and the C920 goes USB to the computer as well. And then I'm using OBS to arrange all the windows and stuff. If you have more questions, feel free to ping me on Discord, and I'm happy to ask. Okay. Couldn't get through the install. I like Arch because it doesn't have any desktop stuff automatically. True. Yeah, I have Mac on my laptop. I've stopped using it as much. I used to use the laptop docked to everything, but the other nice thing about a desktop is that it can control heat a lot better than a laptop can. I wish I had your media equipment budget. Thank you, Adafruit. They paid for all. Well, they didn't pay for the C920, but they paid for the hover cam, the Sony, and the and the Magewell. The Magewell was a recommendation by Phil along with the Hovercam as well. And then I found the Sony one and was like, this is a good camera, and I've been very pleased with it. Okay, let's wrap up. I've been chatting. Thank you all so much for hanging out during this deep dive. Thanks again to LadyAda for stopping by and letting us to chit-chat all the technical stuff. Thank you to David, DCD, for taking notes. I really appreciate it. And also thank you to Luke for helping me out with all the RP2040 stuff. It's a very cool chip, and as always, we're just getting started with everything. So stay tuned for more improvements on the RP2040 stuff till we get it kind of like all settled out for all the boards. And then we'll move on to some other fun CircuitPython stuff as well. So as always, thank you everyone for hanging out. And next week will be on Friday. It'll just be a bit shorter because the vet afterwards. And this time I'll give Vin some pets here at the end instead. So let me switch to cat cam. Hi, kitty kitty. Meow. Is it too cold? Should I close the window? All right, have a great weekend, everyone. Yeah, I'm gonna go get outside.